Okay, today we're going to actually start looking at the trig ratios, sine, cosine, and tangent. And all we're going to be doing today is just matching up the sides that go with each of those ratios. Okay, so for a triangle, and with the right triangle, we always have the hypotenuse across from the right angle. Okay, so here's my right angle in the bottom right, and the hypotenuse is always opposite that, right? So we've learned that already when we were doing the Pythagorean theorem. We said that was our C. It's always going to be the hypotenuse that's across from the right angle. Today we're also going to start looking at opposite and adjacent sides. And to know what side is opposite and what side is adjacent, we have to look at our reference angle. Here we have a theta sign, which represents an acute angle in triangles, and that theta sign is going to be our reference angle. So that's going to be our starting angle that we're going to kind of look from. So from that reference angle, you go on the other side, that is always going to be the side that's opposite, okay? And then the side next to is going to be the side that's adjacent. Adjacent means next to. Our reference angle is always going to be created where the hypotenuse and the adjacent side meet, okay, for our reference angle. So we're going to use that opposite, adjacent, and hypotenuse to create our three trig ratios, okay? So the trig ratios, which create this acronym SOHCAHTOA, represent sine, cosine, and tangent. And all we're going to do is just match up the sides of those lengths to create these ratios. Today we're just going to practice finding the opposite side, the adjacent side, and the hypotenuse based on the angle we're given. Okay, so sine, is always going to be our OH. Okay, so it's going to be the opposite over the hypotenuse. So I'm usually just going to write OPP. I'm going to go ahead and spell it opposite here because that's what it represents. And then in the denominator, we're going to have the hypotenuse. So sine is the ratio that's made when you take the length of the opposite side over the hypotenuse. Okay, cosine is A over H. So that's going to be my adjacent side over the hypotenuse. Over hypotenuse. Okay. Tangent is TOA. So that's O over A. So that's opposite over adjacent. All right, so we're going to practice finding these trig ratios down below. So if we look at this triangle here, we're going to start out by finding the trig ratios for the angle T. Okay, so I'm going to go ahead and mark in blue my angle T. Okay, and we're going to set up the ratio, which for sine was the opposite, over here the 7, was the O, over the hypotenuse, H. So my H is here, 25. Okay, so over H. The next one, cosine. Cosine's adjacent over hypotenuse. So 24 is the side next to angle T. Remember, adjacent and hypotenuse make up my angle there. Okay, so I'm going to go ahead and write the number. 24 is the adjacent, so I'm going to put 24 over the hypotenuse, 25. And then the last trig ratio, tangent, is always going to be the opposite side over the adjacent. So here my opposite side is the 7. And my adjacent is at 24. Now we're going to do sine, cosine, and tangent of C. This one I'll do in red. Okay. I'm going to underline the C here. And from C, the hypotenuse is still the 25. The hypotenuse is always across from the 90-degree angle. Okay. But from C, the 24 is opposite, and the 7 is now going to be the adjacent. Okay, remember adjacent and hypotenuse always make up the angle, then opposite is over on the other side. Okay, so sine of C, sine is over H. I can write that out if I want. Okay, opposite over hypotenuse. Opposite's 24. Hypotenuse, 25. Cosine C. Adjacent over hypotenuse. A over H. Adjacent is 7. Hypotenuse is 25. And then tangent, opposite over adjacent. Opposite is 24. And adjacent is 7. Okay, so if you notice, if we look at these, the sine of t ends up being the same thing as the cosine of c. Cosine of t ends up being the same as sine of c, and then the tangents just kind of flipped, right? The numerator became the denominator, and vice versa. Okay, so let's move on to the next one. We have sine of A, cosine of A, and tan of B. We'll start out with that. We'll do, again, I'm going to mark the A angle with blue. Okay, the hypotenuse is always on the other side from the 90-degree angle. Then my opposite, so we're here the 3, and my adjacent is the 4. Our angle, reference angle, is always made up of that adjacent and the hypotenuse side. Okay, so sine of A, 3 over 5. If you want to write the over H because it helps you remember, go for it. Okay, cosine of A, cosine's adjacent over hypotenuse, so that's going to be 4 over 5. And then the tan of A is opposite over adjacent, 3 over 4. Okay, sine B, opposite over hypotenuse, 3 over 5. Oh, excuse me. Oh man, I messed up. I'm sorry. I'm doing B this time. So B, I'm going to do in red again. B, we have the opposite. Hypotenuse is still 5. And then the adjacent, always made up of the adjacent and the hypotenuse, our reference angle. Okay, so sine of B, opposite over hypotenuse, 4 over 5. Cosine B, adjacent over hypotenuse, 3 over 5. And then tangent of B, O over A, 4 over 3. Okay, the trig ratios and special right triangles, we'll do those when I return on Wednesday. And I'm going to let you guys go ahead. There's a Delta Math assignment that just practices finding the opposite, the adjacent, and the hypotenuse, and finding those sides based on the angle that you're given. I'll see you guys on Wednesday.